So basically, in order to fully characterize this, I have to calculate for all 112 possibilities. We're not going to do that. We're going to, what we're going to do is we're going to realize that all we really need is the variance of this term. So we're not actually going to calculate that. We can calculate it in specific examples, but this example is enough to show us that, I mean, basically what you need to do in order to do this, I mean, it's a straightforward calculation. You just have to do it 112 times. So we're not going to do that in class or on a test. What do we really need to know? What we really need is, so it's noise, this interference term, Sx dot S K V1 V2, 2 of user 2. What we really need, this is noise, so what we're really interested in is the variance. So again, in order to calculate that, once again, you have to go through all those possibilities. So this quantity will generally be given to you, at least as far as this course is concerned. Now, it is possible, of course, it's possible to calculate that variance, but not without, basically not without a computer program to do it for you. So what we really need is this variance. So we know that. Remember that if I have random variables A and B, and I have A plus B, and I want to know variance A plus B, if A and B are independent, what is that? It's variance A plus variance B. So remember from a second ago, we had this. The output of the matched filter was my signal plus my interference plus the noise. Excuse me. Before I just realized before when I wrote this equation, I replaced this with N0/2TS. What I actually did there, this is the actual value. What I actually wrote in there was the variance, so that's possibly not correct. So I should have just kept it like this. But what's important here is that we're grouping the interference with the noise. So what I want to do, what we want out of the noise, so remember way back to when we were first talking about probability var, what we want to know about the noise is its variance. So basically, this is what I need to know. Now, the question is that independent or not? So what is this dependent on? This is dependent on K, the delay between the two users. It's dependent on these, and it's dependent on these two bits, B1 and B2. Those are the only random things on this side. On this side, the randomness is inside the receiver, this thermal noise. So those physically have nothing to do with each other, so we can reasonably expect that those will be independent. Okay, var n.sx, this is where that comes in. This is equal to, let's call this term V2. So that's the, actually this is the variance of the second user with respect to the first user. So let's call that V 1, 2. Plus, so that's this one, and this one is equal to N0 over 2TS. So basically, everything that we do with, everything that we've done in the single user case, all we have to do is take the variance expression and throw this in. So it's all the same, just boil it down to here. That this variance, it's important to know that it comes from here, but this is too complicated to sit down with pencil and paper and scratch out. So basically you would be given this, and then everything else is the same. Now, another thing to think about is, what if we have more than 2 users? If we have more than 2 users, then what do we have? My signal looks like this. Alpha 1, S1. So again, I'm synchronized to user 1, and then every other user is offset. So we have, this is user 1, user 2, my expression was this. Now if I have extra users, I can just write them in like so, they're just additive. For convenience, I'm just going to keep writing these values the same, even though that K could be different from this K, these bits could be different from those bits, and so on. And so on, plus noise. So again, if I take the matched filter, what I get is the signal plus interference from user 2. I'll just let's just short form this as S2 sub right arrow, because I don't want to keep writing that all the time. Plus SX dot S3 sub right arrow plus SX dot S4 right arrow plus, and so on for each user, plus the noise. So this is my signal. All of this is interference plus noise. And finally, what I say is that the variance of the interference plus noise the variance of all this stuff is basically the sum over all the users. So it's J equals user. All the interference users are numbered from 2 to the maximum number of users. Let's call it U of variance SX dot SJ, right arrow, plus the variance of the noise, which is N0 2TS. So basically, again, it doesn't matter how many users you have, the total variance is just given by this. So that's the only difference to the single user case is that you have to add up all of the variances that that compose the signal.